Hi all. So, over there you can see Bob and Margaret. Bob and Margaret have just moved into the neighborhood and they like to tell everyone that they have moved in, especially at about 3 o'clock, 4 o'clock in the morning. Yeah, so they are very popular, but at least someone has a social life around here. Now, why are Bob and Margaret important to this lesson? They're not. They're just something I can watch over my gate. What is important to this lesson is the content we're going to start covering, and that is simultaneous equations. So now the question is, what are simultaneous equations? They are equations that we do at the same time. That's why we call them simultaneous. I know, it's amazing. Okay, so simultaneous equations have more than one variable in. So that means if we have two variables to solve for, like x and y, we would need at least two equations to do that. Why? Two variables, two equations, and we use them to solve for each other. There are different methods we can use to do them. We give them fancy names, so you can solve them by elimination. You can solve them by substitution. That's personally my favorite method. Or you could solve them by plotting them on a Cartesian plane. That can be difficult to get accurate, so we're not going to spend much time on that at all. In fact, we probably won't do it. We'll just tackle that when we get to straight lines. Okay, well, with that introduction, I'm going to say goodbye to Bob and Margaret, and we'll get on to some other work. And we're back. Okay, so solving simultaneous equations, you'll see in this particular equation, or this particular set of problem, we have got x, we've got x, and we have got y and y. Now the important thing to note is that this equation over here is completely independent of that equation over there. This one exists, x plus y equals minus 1, separately from this one over here. 3 is equals to y minus 2x. Unfortunately, if we only had that one up there, so let's just show you what I'm talking about. Let's say we didn't have that. We would be able to get an infinite number of responses or values that would work for that. Let me show you what I mean. So we could say that x has a value of 3, which means that y would have a value of minus 4, so that we could get an answer of minus 1. But that's not the only combination that could work. We could say x is equals to 14, which means that y is going to be minus 15 in order to get to minus 1. How about we say that x is equals to 752. Actually, let's even make it negative. So that means that y would have to be 751 in order for us to get to negative 1. Now we could go on like this forever and ever and ever and ever. The number of solutions are infinite to make that work. However, we don't want that. We would like to know the exact value that x and y are going to be in this situation. In order to do that, we need to figure out what the value, let's use some there, what the value of x is by using the other equation to help us, and what the value of y is to use that equation to help us. Do you see the problem though? The problem is we have two equations that are completely independent from each other. We've got this one up here, x plus y is equals to minus 1, and over here 3 is equals to y minus 2x. And they look quite similar to each other, don't they? Which means we could, as we go, get them muddled up with each other. You know, like I have identical twin nephews, and sometimes I call Jack Tom and Tom Jack. It's that kind of thing. So how do we avoid this? We give them names. For example, I could call the first one Bob. let's give him a capital letter. And the second one, Margaret. Okay, my problem is that my spelling's terrible. And I'm going to run out of space to write that stupid long name. It's not a stupid name, it's just because it's long. I'm sorry if you have a relative called Margaret. Okay, but back to it. Mathematicians were lazy, or we like to say we're efficient, so let's give them a name that represents our efficientness. It's highly imaginative. We're going to call this first one equation 1. And the second one we're going to call, guess what? Equation 2. So from now on, when we're using the first equation, we're going to say just equation 1. We're not even going to say equation or write equation, we're just going to write down the 1 and write down the 2. The big thing with simultaneous equations is that you need to be able to explain what you're doing using maths. In other words, all those symbols that you need, you know what they are. And words, it's very particular what you've got to do. But there we go. Now the other thing to be aware of is that these calculations can often take up a lot of space, which means that they go on and on and on and on. I mean, I've done some that have taken up half a page. That doesn't mean they're difficult, it just means that there is a lot to say. That is why structure and format is so important. You need to pay attention to how you are laying things out. You need to put spaces between different parts of the calculation and also carry on explaining what you're doing. Why? Because someone else has to read it. Okay, with that being said, we're not going to do an example in this video, but what I am going to do is give you a quick rough guideline of the steps we do it. The first step, no matter what method you use, you need to name your equations. Generally, those names are going to be 1 and 2. And by generally, I mean pretty much all the time. The next thing you need to do is to manipulate the equations to suit your chosen method. Remember, there are 3 different methods. We're going to cover 2 of them. So you will manipulate the situation to suit your needs. It's like real life, just like that. And then lastly, you are going to solve, firstly, for one variable, for one of them, and then you are going to substitute that in to solve for the other one. So there are basically 3.5 steps to solve for the other one. Sorry, I left that part out. Here there. Now I'm putting an S in. Please laugh with me, not at me. So there are the 3 parts, and the third part is kind of 2 parts. The first part of the calculation is to name the equations. They're going to be named 1 and 2 rather than Bob and Margaret. The next part is to manipulate the equations to suit your needs, and the needs will be based on what method you are choosing to use. And yes, the method is your choice. You don't have to do a particular one unless the question asks for it. And lastly, you're going to solve for the variables. You're going to first solve for one of them, and then you're going to use that value to solve for the other one. So it's like a 2-part to that particular one. Okay, well, darlings, that is it for now, and I'll see you in the next video.